Hi everyone. In this video we are looking at section 4.5, solving radical equations involving square roots and also involving variables inside the radical. In this case we are looking at example 1c. We're given a reminder here that the value under a square root must be positive because, as you know, we cannot take the square root of a negative number. Similarly, when we take a square root, our result is a positive number. In this case, we have a bit of a strange situation where we have the square root of x plus 2 equaling a negative 3. Let's go ahead and solve for x, and then we will verify whether or not our answer is actually the solution. So in this case, we have the square root of x plus 2 equals negative 3. We want to isolate and solve for x. In order to do that, we have to use the inverse operation, which in this case, because we have the square root of x plus 2, we need to square it. That will essentially cancel the square root. So we will have the square root of x plus 2, and we will square that, and of course that equals negative 3 also squared. And don't forget to use the brackets here, because if you just write it as negative 3 squared without the brackets, then really you're only squaring the 3 and you're not squaring the negative. And of course we have to square the entire whatever is on the right side. So in this case, negative 3 must be squared. In our next step, because we have squared the radical goes away and we just have what's left, which is x plus 2. And this, of course, equals a negative 3 times a negative 3, which would be positive 9. Now, in order to isolate the x, we have to undo the fact that there's plus 2. And of course, the inverse operation to adding 2 is subtracting 2. So we are going to subtract 2 from both the left side and the right side of the equation to keep it equal. And now when we subtract the 2 from the left side, we have x plus 2 minus 2. So of course, plus 2 and minus 2 would just give us 0. So we were just left with x equals 9 minus 2, which is 7. So now we have a solution, potentially. We know here our workings tell us that x equals 7. Our last step, of course, in this process is to verify that 7 is actually a solution. So we rewrite the original equation, and now in place of the x, we will test if 7 works. So now we have 7 plus 2 possibly equaling negative 3, or rather the square root of 7 plus 2 equaling negative 3. And we're not sure, so we write a question mark there, and we're going to follow the process to see if the left side equals the right side. 7 plus 2, of course, is 9, so we have the square root of 9 maybe equaling negative 3. And when we take the square root of 9, of course, we know that is 3, which does not equal negative 3. And again, we kind of noticed this at the very beginning, at the outset, when we had a radical, or a square root rather, equaling a negative number. So of course, in this case, we created what's called an extraneous root. This positive 7 here that we found to x to equal was actually an extraneous root. And in this case, all we write is that our concluding statement is that x equals 7 is not a solution. Because, of course, 3 does not equal negative 3. When we tested the value 7, we realized it actually does not work. So 7 is not a solution